Happy Friday, everyone. Let me begin the lecture so I can get you guys to your weekend. I see the numbers are already beginning to dwindle. So good. I'm doing my job, right? Keeping the attrition rate high. So today we're going to be talking about strings, indexing, and slicing. And this is somewhat exciting because to get a new data type is cool, but this data type is somehow real, right? It's very close to a list or a set. So this is a much more sophisticated data type than anything that we've given you so far, right? So what is a string? Well, anything, with some exceptions, but nothing really you need to be concerned about. So anything enclosed by single quotes or double quotes is considered a string by Python. So a string, technically, is an ordered collection of the characters, and characters are defined by organizations. Right? So the fact that you hit A and A shows up on your computer seems obvious to us in the Western world, but if you type A somewhere else, you may get something crazy, right? Someone brought me their European keyboard and there was a lot more characters on it, right? So there's an institution of people who decide what characters are available on a computer, and they have some giant table where it's ASCII 4 is A, ASCII 6,753 is the winky emoticon, right? These are real people who have to sit down and approve emoticons. I wonder how much they get paid. Not enough. Okay, anyways, anything enclosed by quotes is a string. So, what have you learned? Hello world, enclosed by quotes, is going to just return hello world, right, with quotes around it. Right? This is important, but we'll discuss that nuance later. If I ask for the type of hello world, it's going to tell us that its type is a string. Right? So, indeed, I have given you a new data type. If I type hello world without the quotes into the compiler, what's going to happen? What kind of error? It's close, but not quite. So what does Python always do first? It checks for syntax. Right? Is this appropriate syntax? No. So it says, sorry, this is invalid syntax. Okay, if I were to just type in hello without the quotes, now what would I get? Name type error. It's saying, well, you didn't define a variable called hello. So what are you talking about? What's Python saying, right? So be very careful between putting quotes around strings and leaving those quotes out, right? It's all these little details which end up confusing new programmers, right? Because you say, well, I typed hello world and it gave me an error. Yes, but you needed to put quotes around the hello world. I know it looks virtually identical, but the little details are basically the only thing that matters in this discipline. So now that we have a new data type, we can operate on that data type. For instance, I can add two strings together, and this is called concatenation. So if I add hello and world, what do I get? But how is it different than the hello world I've been showing you before? No space, right? Because I didn't include a space. So, what is the type of empty? Well, excuse me, that's also a string, right? So the empty character is a string of length 1. So I can assign that to a name. Maybe I'll call that the empty string. And now I can say hello plus empty string plus world. And that's going to give me hello world as we expect it to be. Small note that we'll discuss a little bit more at the end of the lecture is that new strings are being created. When you create hello, the computer says, I'm going to put hello here. When you create world, it says, I'm going to put world here. And when you say, please add those things for me, it's not going to create a rule that says, okay, I've added these two things. It's going to say, okay, I'm going to go here and copy hello and then copy world. Right? So new strings are getting created every time you operate on them. In addition to adding things together, we have an additional binary operation, which in this case is a predicate, which remember is a function which returns true or false. So we can expect to do equality on strings, right? So in some languages, string equality is done via memory address. So we'll say two strings are only equal when they occupy the same space in memory. Python is sort of more sensible about this. Since it's a higher level language that we're using to learn, I think most of you would expect that this would evaluate to what? Well, what would you like it to evaluate to? Okay, so indeed it does evaluate to true, right? Because the PEP people determined that that's fairly reasonable. What about this? No, right? Because one has a tailing space, so space matters. These aren't the same string, right? Even though something is empty. What about this? False again, right? So I think we get the point. In order for two strings to be equal, they have to be exactly equal at every position. What about this? Hello is equal to hello. Also false, right? Because capital H and little h, despite being the same character somehow, are just seen as different things by the computer. The computer doesn't care that one is a capital case of the other. So this is interesting. In addition to comparing strings via equality, we can actually compare strings via inequalities, which you may not expect. So remember, humans had to create Python. So they sat down and they said, well, geez, if you wanted to compare A and B, right, should A come before B? Well, I think if we imagine the alphabet, right, A, B, C, D, E, F, G, it's sensible to say A comes before B and B comes before C. So what would be the sensible output here, right? True, and in fact it is true, right? So they were sensible about these definitions. What about capital A less than A? Think that's false? You willing to bet your first child? First child, mate. Actually, I don't want any children, so you keep. Okay, so what can we conclude from this, right? Capital letters are ordered before small letters, right? So to make that a lot more clear, is capital Z less than little a? True, of course true, right? So all the capital letters are ordered before the small letters. And I'm not going to test you on this. This is just for interest to show you that strings are fairly robust somehow. All right, so who wants to gamble their first child? Right? What should be less here? First child? Okay, you can have his, right? Because I already won his. A sensible way of ordering strings. Can anyone give me an example of a giant tome that orders strings? A tome is a book. Jesus, Murphy, guys, read a book. Read a tome. What's a dictionary? A dictionary is an ordered collection of words, right? So, what would appear first in the dictionary? A or double A? A. What would appear first in the dictionary? B or double A? Yes, so that is correct. B fails to be less than double A. Double A is greater than B. Oh, I can show you the thing I forgot to teach you. I forgot to teach you something. I figured I should probably teach you it. Okay, the thing I forgot to teach you. We have two functions, and I wonder if you could figure out what they will do. It's pretty tough, so I feel really bad for not showing you this. What is the maximum between 1 and 2? What is the maximum between 2, 6, and minus 9? Okay, so there's a maximum operator which will return the maximum of something. There's also a minimum operator which returns the min. Right? That's what I forgot to teach you. So there is a min and max operator. Feel free to use them. Okay, end of tangent. Right? So great. So I didn't fail to teach you anything. Because remember, like, I've been yelling at you guys to not use tools that I haven't given you to solve problems. It turns out this whole time we had min and max as tools, which meant I could have made more robust problems. Like, for instance, I could have said, without using if statements, return me the second smallest thing, right? So that's actually a good question. How can you use min and max to return the second smallest thing, right, without using an if statement? But this is interesting now, because now we can really test this. What's smaller, B or double A? And it will say double A is the smaller thing. Right? So this min and max are quite robust. You can put any data types in them. What you can't do is mix data types, right? The things that you're asking min to operate on have to be comparable in the first place. So it's going to say, I don't know how to compare a string with an integer, you crazy programmer. Okay. More on this. What comes before the dictionary, ABA or AB? So this should be false. ABA is not less than AB. Okay, but our dictionary is super weird, right? Because the real dictionary doesn't include capital letters, right? So our dictionary has like a larger ordering. So what should this be? What would come first in the dictionary? AZ, capital Z, or AA? Okay, so we compare the first characters and they're equal. We move to the second characters, and Z is less than A is true. Right? So we find that this is true. Again, I'm not testing you on this. It's just interesting that strings can be operated on in this manner. The mathematical terminology for dictionary ordering is graded lexical ordering. And if you're interested in that type of stuff. Okay, so now that we can print stuff, or I'm giving you the ability to have strings, there's a couple special strings, or there's one special character that you have to be aware of. And this is the backslash, or what we call when we're printing an escape character. So why is it called an escape character? Well, the program is going to read left to right. As soon as it encounters the backslash, it's going to say, oh, okay, hold on. This is now something different than printing. I'm going to be given an instruction. So in this case, if you give the escape character followed by an N, the instruction that you're issuing is start a new line. So here's how you use it. So I say hello world, and I print it. I say hello world, I type it into the compiler. What gets printed? What are you willing to bet? Because oh man, your legacy is done, right? Because you're. Oh yeah, so I guess you return his first child to me, right? This lecture is just heading to weird directions. But okay, but this is important. Why? Like we were expecting this to print a new line. Okay? So, remember how I was like getting all bothered about printing, right? This is not printing. This is Python just spitting back at you what you've typed, right? Which is what you should be used to, right? 2, okay, you've typed 2. 4, you've typed 4. Hello, you've typed hello, right? It's saying you've given me a string. What do I have to do to get the new world? Well, I have to print it, right? The escape character is an instruction for the print function, right? So when I print this, notice that there are no brackets. There's no more quotes, right? Because now it's saying, oh, you've given me a string. I have an instruction to print that string, so here it is, right? So these escape characters only get instantiated by the print function. Otherwise, Python is just going to say, yeah, okay, you've typed in hello-n world, so here you go. I'm storing hello-n world for you, and I'll do something with it as soon as you tell me to do something with it, right? Okay, so let's see if you have absorbed that. The next escape character I want to tell you about is the tab character, and a tab is a fixed amount of horizontal space, and how a tab is displayed depends on the software that's displaying it, which is why tabs are the worst, right? So there's a big tab versus space argument within computer scientists. So I use spaces because every piece of software is going to display a space in the same way. Now, to give the other arguments some fair treatment, those who are pro-tabs, those dirty rebels, would say that a tab is 1 character, whereas 4 spaces is 4 characters. Right, so thus, the programs using the tab character are smaller. But we now have terabytes of space, so that's hardly relevant. So anyways, let's see if you've absorbed the last slide. Right, I type into Python hello escape t world, and what gets printed? Same thing. Okay, child returned. Okay, now I print this, and what happens? Okay, now you're going to get a space, right? Because printing is a function which does something, whereas typing something into the Python interpreter is not doing anything. Okay, so I want to show you how this escape character is sort of working, right? Because I was trying to determine last night how many spaces is actually put in, and I thought it looked like 3. So let me do this. I can say hello world, right? I can print hello world, right? And notice that the quotes are gone. Now I can print hello tab world and maybe a new line A. Okay? So I copy this into my IDE, right? And what is it going to show? Oh, I turned off new lines. Well, whatever. You see this? That's the tab that you've put in there, right? It's not 4 spaces. It's this. This is a tab. And my IDE somehow displays it as 4 spaces. or 3 spaces, right? So you're literally putting a tab character into that string, which is a single character, not 4 spaces, right? So printing a tab is different than printing 4 actual spaces. Escape characters. Okay, so this begs the question, how would I print -n? What happens if I wanted to tell the user, hey user, you forgot to put in your escape character? Well, turns out you can escape an escape character. If you put an escape character and then the escape character again, it will print the backslash. If you put an escape character in quotes, right? How would you print quotes if everything being inside quotes is being interpreted as quotes? Well, you can say escape quote, right? So how can we print literally this, right? -n, /n/t/ comma. I'd have to print it like this, right? I would say //, which gives me a slash, then n, then //, which gives me a slash, and then, oh, I missed a slash. That should be / comma. So there's also a mistake on page 10. And that will print this. Again, not too important, just in case you ever find yourself having to print something that has been reserved as an escape character. Numbers versus strings. Numbers are not strings, right? So this is something that is very confusing for new students as well. It's not a trick question. What is 3 plus 10? 3 plus 7 is 10. Okay. This is a trick question. What is 3 plus 7? 37. Right? So, the add function is contextually sensitive to the types that are being given to it. So remember, plus is really a function which takes 3 and 7. We just got to write it in this way because it's a binary. So this says 3 is an integer, 7 is an integer. Okay, I know how to add those. Oh, 3 is a string and 7 is a string. Okay, I know how to add those. In this case, I should concatenate them. What happens if I try to mix computations here? It's going to get an error. It's going to say, I don't know how to add an integer to a string, right? Because they have to be the same data type. What about this? I cast 3 to a string and that adds 7. 37. What about this? I take 3 and I cast 7 to an integer. That was surprising to me, actually. Most computer programs wouldn't cast 7, the character, to 7. That's a strange behavior by Python. Normally, if you were to cast a character, what it would return is the ASCII value of that character, right? That's one way of casting characters to numbers, right? So to re-emphasize this, so what is 3 plus integer 7? That should be 10. Okay, so this shouldn't be string. This should be float, right? So any number which is a string, which is a valid number, will cast to itself when run through the system, right? So let me just do this. Float of 123.456 gives you that number, right? I can't do this, right? Because that ceases to be a valid number. So this is a strange behavior by Python, which makes some questions easier. It's kind of sensible to let numbers go to numbers when you're casting them. However, if I ask for hello, the string, to be cast to an integer, it doesn't know how to. Even though we could probably come up with some type of injection which could do it, right? We could take the product of the individual strings, right? So just be aware of this, that if you cast a string which happens to be a valid number, you get that valid number back. Something you may require, right? Suppose you wanted to write a program which prompts the user for their name and their age, and you want to print user's name is this, user's age is this. You'd have to use, well, you could write a really long statement with pluses, but there's a substitution command which will expedite this process. So if I say x is hello, I say y is world, because I can set variables to strings, why not? And then I set z to this funny looking string, right? So if you use these curly braces like this, what this is telling Python to do, so I'll run left to right and it will find this and it will say, oh, I should put x in there. Then it will print this, and then it will go here, and then it'll say, oh, I should print y in there. So if I print z, it's going to end up printing the string hello world, right? So you can actually get pretty fancy with these. There's a bunch of options that you can put in these curly braces. For those of you familiar with C, so you can get the same, you can sort of set the precision, you can set the width, and all that fun stuff if you But just go look in the manual for that kind of stuff, because I don't care about print. There are other built-in functions that operate on strings. An important one is the length of a string. So what is the length of h, sensibly? It should be 1. Right? What is the length of hello? 5. What is the length of world? Oh, sorry, x is world. What's the length of x? 5, right? So I'm asking for the length of the thing that x is equal to. I'm not asking for the length of x itself. X isn't even a string. X is a name. It wouldn't make sense to ask for the length of something that is not defined yet. So be careful of this nuance, because it's a good way to trick you on your exam, is to ask you for the length of x. Generally, it is the case that length has this property. So you can take hello world and find the length of that, and that's going to be equal to the length of hello plus the length of world, right? So you can distribute the computation like this. So that should be true. The reason that strings are now interesting, or they're sort of somehow the most robust data structure that we've been given so far, is because they can be regarded as a mathematical collection, a set, right? It's a set that's ordered. It's a set that can only use specific characters, but it's a set nonetheless. And since it's a set, we can use set operations on strings. And this is my most favorite function in Python, this in operation. We're going to get a lot of leverage out of in, because I can show you how to make really crazy list comprehensions and set comprehensions. We can solve problems very quickly by writing very concise mathematical statements that include set operations. So, is the letter H in the collection of letters hello world? True. Is hello in the collection of hello world? Is X, I set X to world, is X in hello world? True. I'm not asking if X is in hello world. I'm asking what the thing X is set to. Is that in hello world, right? So be careful with this kind of stuff. Is OW in hello world? False, right? O space W is in hello world. And I guess I should point this out. What is going on? That order matters. So if I ask, is LEH in X? False, right? It's looking for these. It's looking for the. It's not doing inclusion individually. It's looking for that string pattern in the full string. And so just play around with that. We're going to do so much more with in. Whoa. Is it okay? Screen's not cracked? We're good. We're good, everyone. We're good. Device is alive, right? Okay, so this is where things are going to start getting a little bit complicated, right? Now, because we have an ordered collection of strings, or an ordered collection of letters, we can now number the letters, right? We can say that the first letter is 0. Okay, so the natural numbers start from 0. So for mathematical reasons, when we start counting on a computer, we start counting from 0, right? So I can use square brackets to access the individual letters of this string. So the 0th letter will be H. The first letter will be E, right? And so on. The length of X is 11. So what is the 11th position of X? It's error. Why is it error? Okay? Because we start from 0. Right? So if we have 3 objects, that's 0, 1, 2. The last thing we have access to is 2, despite the list having length 3. So remember this nuance, right? So the last position of the list is list minus 1, because the first position of the list is 0. Right? So everything gets shifted a bit. Okay, but good news, right, about this nuance. We have negative indexing in Python, which is cool, right? Most languages don't have this, right? So list manipulation in Python is very robust, right? So I can say hello world, and I can say give me the last character from the back, the first character from the back. That's going to give me D. I could say give me the second last character from the back. That's going to give me L. I can ask what's the third last character from the back? R. Right? So you don't ever really need to ask for x at length of x minus 1, because you just ask for the last character. Give me the last character, which is at the -1 position, right? So negative indexing is very cool, right? It'll help you simplify your code quite a bit. Any questions regarding that? Because it's just going to get more complicated now. All right. Okay, so since the characters themselves are numbered, right, I can now show you a way to take some of them but not others. I can show you how to generate a pattern to say, let's take this region of the string. So I'm going to stop using hello world, and I'm going to use this string, which is just the digits 0 through 9, because there's going to be a one-to-one relationship between the index and what's being printed. Right? So if I print x of 3, 3 is at the position x of 3. 0 is at the position x of 0. Right? This is going to save us from having to like number the letters. Right? So this is a very special example where the number is equal to the position that it's sitting at. Right? So maybe you should go over this example again and use a string. Okay, so here's some notation. You could put in square braces, you can use a colon, and I can say, give me the numbers 1, so give me the numbers from position 1 through position 4, but exclude position 4. Right? That's our right boundary. Right? So what would this print if I go if I get positions 1 through 4 and exclude 4? 1, 2, 3. Okay? What happens if I ask for the numbers from position 0 through position 9, excluding position 9? 0 through 8. So in order to get the whole list, I actually have to go from position 0 through position 10, which doesn't actually exist, but since it's the boundary, it doesn't matter, right? So 0 through 10 is the numbers 0 through 9 inclusive, right? So we get this. And so, but again, since we have negative indexing, this is not the way that we should do it. We should do it this way. Right, so here's my string again, and is the last position equal to the position at the length of x minus 1? Yes, yes it is, right? So, what will this print? This is the third position to the last position, excluding the last position. 3 to 8. So, as you see here, right, so I would sort of expect this to give me the whole list. How would I say give me position 3 to the end, right? I thought minus 1 was supposed to be the end, but since this is excluding it, this is a problem. So to get 3 to the end, I just don't put anything there. This is notation to say 3 onward, right? And the reason we have to say 3 onward is because you can have a list that is of infinite size in Python. Right? You can have a list of length infinity. They're called streams. Right? So I can then say, okay, from the stream, give me 3 onward. Right? And so this is a meaningful notation. So 3 onward is going to print 3 through 9. Right? And it would have printed anything after 9 had it been there. So what should this print? It will print everything. It's going left all the way and right all the way. So that's a way to get the entire list back, although you could just have typed x. What will this print? It will print from the -7th position inclusive onward. So just count from the end, right? 7 times. And where are you? 9 is -1, 8 is -2, 7, -3, 6, -4, 5. Oh, I screwed. It's 3. The answer is 3. Right? The thing at the -7th position is 3. Right? So it's going to print 3 onward. So it prints that. Right? These slices are very, very useful. Right? And I'll show you why they're so useful next slide, I think. Okay, so one more piece of notation for slicing. I can give it a third index. All right, so you give it a left, inclusive, right, exclusive, and then an additional number, which is the thing that is telling you what to skip. Right? So if I write this, this can be interpreted as print out all numbers starting from position 0 to position -1, excluding -1, and skip every second character. Right, so given that 0 is included in this, what will this print? 0, 2, 4, 6, 8, and then 10's already too far. So it gets 0, 2, 4, 6, 8. So before I print this, I've made a mistake, right? That should be 0, 2, 4, 6, 8. Right, so I'll fix that when I go back to my office, right? So I can prove it if you want. So there's my, nope, my x is this, right? What was I printing? I think I was printing 0, negative 1, 2, 0, negative 1, 2, right? 0, 2, 4, 6, 8. What will this print? I want to go from the first position to the position -3, exclusive, and count by 3. So what should the first number be? 1. What should the second number be? Then, should we go all the way to 7? 7's on the boundary, right? So we get 1 and 4, right? So the sequence is 1, 4, 7, 10. But where should I stop? It says stop at 7. But 7 is to be excluded, right? It's the open brace range, right? And there's good reason for that, right? Because I want to be able to say, I go from 0 to the length of the list, right? And that will account for the +1 indexing. There's good reason for it to be exclusive, which we'll appreciate later when I give you ranges. Okay, so what does this give? And so left all the way, right all the way, skip by 3. So we get what? What's the first number? 0. Then 3, then 6, then 9, right? All of it falls into the, so the range is everything, and we're skipping by 3, and we start at 0. Whole list, and I walk by -1. Any guesses?
Doesn't it just reverse the...
It reverses the list! How cool is that? Yeah, usually... It is very cool. So reversing the list is something that typically is like a problem that we give to undergraduate students. The fact that you can reverse a list so compactly is incredibly useful. Yeah.
If it's x double colon -2, then it would go like 9, 7, 5, 3, 1.
That's a good question. Let's see. Okay, so I showed you that we can reverse the list by doing this. The question is, what's the first number if we go by -2? So my intuition is that we still start at 9. So the next number should go 9, 7, 5. But that may not be right. Yes, I'm right, right? Okay, because it's at the end of the list and it moves backwards, right? So you just have to go into the lab and play with this a bit to get a good feeling for it. Yeah, so I can, I already had that example. I can walk the list backwards by 4s, right? So it starts at 9, then to 5, and then to 1, right? So list comprehension is something that is incredibly useful. We're going to be utilizing it quite a bit later on. So I want you to go to the labs and sort of play around with this and get comfortable with it. Okay, so last slide, and then I have a question which we'll do together, and then I'll let you guys go enjoy your weekend. Right? So something is immutable when it can't be changed. Like 2 is immutable within Python. You can't say 2 is equal to 7. Python will just reject that, right? It's a value. So is true. So is false. Strings are also immutable in this way. So you may be tempted at some point to take a string. Suppose I gave you a question that said, take a string and convert the string to a title. Right? That is, every first character has to be capitalized. You may be tempted to do this. Right, but Python's going to say, no. Once you create a string, it's unchangeable. It's there forever. You can create a new string if you want, but this one's set. Okay, so the reason I'm telling you this is because you probably won't ever write something like this. You will get the non-obvious error by doing this. You can say in your code, I'll set x to some string, and now I'm going to try and change x, and it's going to give you this error. And you'll be like, what? That's bizarre, right? So just be aware, if you get some type of string object does not support item assignment, you're trying to mute something that is immutable. Right, so strings are just fixed once you have fixed them. Right, so that is an important nuance. Right? I'm just trying to help you guys catch errors before you encounter them. Okay, so the question that we're going to do today together should only take 1 line, but it's good to do it anyway. So let's write a program that takes 2 strings and returns, you know what? You do this. You write a program which takes 2 strings and returns the average length of those 2 strings. do it properly, write a doc string, come up with a good input names, come up with a good name for the function. This should require exactly one line of code, right? Return. So how can we find the average of two strings? How do we find the average length?
Check the length.
Yeah, you sum the lengths of the input and divide by 2. Right, so that's already, so I told you mathematically what the answer is. Now just go and implement it. Next time we meet, we finally get to introduce if statements. All right, so we're finally going to be able to start doing stuff that's more complicated. So we're not fully there yet. If I get loops, then we're off to the races. You guys will be begging to go back to the arithmetic stuff. But next time, if statements, I'll hang around for 10 minutes to answer lingering questions. You guys have a safe weekend. Enjoy the hot weather before winter comes. Because is today technically the last day of summer? Or was that yesterday?
Yeah. Actually, yeah.
Is today the last day of